In the last experiment, I gave a local AI agent 100 synthetic vulnerabilities and asked it to prioritize 10. It found useful signals, but only 3 choices matched the separate analyst rubric, and some explanations invented evidence. This time, I used a safer architecture and made the agent build the remediation plan. It returned all 10 required work items and passed 70 out of 70 structural checks. Every vulnerability ID, owner, deadline, action type, verification field, and rollback field was present. But I still would not execute this plan. The reason is the difference between a complete looking ticket and an approved technical change. I did not feed the model its own unreliable top 10 list from the first experiment. The remediation queue came from the deterministic analyst rubric. Code assigned the responsible team and deadline from known facts. Known exploited findings received 3 days. Internet-facing findings with public exploits received 7. Critical production findings received 14. The remaining items received 30. The agent could not change those decisions. Its job was narrower, preserve the supplied vulnerability ID, owner, and deadline, then draft an action, a verification step, and a rollback note using only the provided facts. The final plan contained 10 work items. 2 were due in 3 days, 3 in 7 days, 2 in 14 days, and 3 in 30 days. Identity engineering owned 2 items, infrastructure operations owned 1, and platform security owned 7. 9 findings had patches available, so the action type was patch. 1 finding had no patch, so the action type was mitigate. No vulnerability disappeared, no duplicate appeared, and the model did not move an item to a different owner or deadline. The deterministic validator checked 7 requirements across all 10 work items. The ID had to exist, the owner had to match, the deadline had to match, the action type had to agree with patch availability, the action verification, and rollback fields could not be empty. That produced 70 passing checks out of 70. This matters because language models often create polished plans while dropping records, changing constraints, or quietly rewriting the priority. The validator prevented that kind of drift. Vulnerability 042 was the known exploited production authentication finding from the first video. Its owner remained identity engineering, its deadline remained 3 days, and the agent drafted a patch action with verification and rollback notes. Vulnerability 016 had no patch available. The model correctly changed the action type to mitigation and proposed a network-level restriction for the affected synthetic production asset. Both records passed the structural gate. Neither record was executed. Look closely at the language. For patched items, the action was essentially apply the patch. Verification was confirm the patch is installed. Rollback was return to the previous version. Those fields are complete, but they are not operational instructions. The source data did not identify the affected package, current version, fixed version, deployment, method, dependency risk, maintenance window, test command, service owner approval, or rollback artifact. The model correctly avoided inventing most of those details, which is good. But without them, the plan cannot safely become a production change. 70 out of 70 means the structure survived. It does not mean 10 out of 10 changes are ready to run. The production workflow needs 5 separate gates. First, deterministic scoring selects the remediation queue. Second, ownership and service level deadlines come from policy and the asset inventory. Third, the AI drafts the work package without changing those constraints. Fourth, technical enrichment adds the exact affected component, fixed version, deployment method, validation evidence, maintenance window, and rollback artifact. Finally, the asset owner and vulnerability analyst approve the change. Automation can create the first draft and catch missing fields. It should not guess the missing technical facts or execute a vague ticket. This second experiment produced a much better result than asking the model to make the risk decision itself. The agent preserved every required record and constraint. It turned a ranked queue into 10 consistent work packages. It also showed why a passing schema is only one control in a real remediation process. Use deterministic logic for priority, ownership, and deadlines. Use AI for drafting and organization. Require real asset data, technical validation, change approval, and human review before execution. If you are finding this content useful, please subscribe, like, and comment. Thanks for watching. I will keep testing these systems honestly, and I will see you in the next one.